You no one tastes chips. Yo, that's what you want. Yo, bro.
He's not my type.
Bro.
Limit n approach infinity a to the n does not equal to 0, then n equal to 1 of infinity a to the n diverge. Now this is called n-term diverge test. N-term diverge test. So this test only proves if it's diverged or not. It does not tell you converge. So I'm gonna say that again. So for example, if you have 2n plus 3 over 4n minus 1, if you have an is equal to this, then you can say limit n approach infinity of 2n plus 3 over 4n minus 1 is equal to 2 over 4. If we reach infinity, divide by highest power on denominator. If it's 2 over 4, then it's diverge. But it does not tell you if it's equal to 0, converge. Never did say that. If you look at here, it never did say that. For example, if a to the n is 1 over n, limits as n approach infinity of 1 over n, that's equal to 0. But does that prove it's converged? No. That means you need other tests to see if it diverge or converge. It turns out we do know one other series because this one is summation of n equal to 1 infinity 1 over n. It's a very well-known series because this is just a harmonic. If the harmonic is diverge. So again, it go to 0 doesn't mean it's converge. It just means it's not for sure diverge. But you still have to test other tests to determine what's the outcome. Is that okay? Okay. Another way to test if the diverge if r is bigger than 1. So let's just say limit, let's just say summation of n equal to 1 infinity of pi over e to the n minus 1. Is that diverge or converge? And why? What? Yep, pi over e is greater than 1, then it's diverge. So this is another way to see if it's diverge because geometric series is greater, r common ratio is greater than 1, is diverge. Is that okay? So that just kind of tell you like which kind of situation you can test different way. So the problem is you guys have to decide when to do what tests. You guys got to be able to convert the thing which was like 0.081 to the fractions. You guys know how to do that, right? Okay. How do I do that? So let's say it's 0.81.
Oh, that one.
Yeah.
You have to do, and then 81 over 10,000, and then 81 over a million.
81
And then you
yeah.
So this one's going to be 81, 81, sorry, 81, 81, 81. Right? It's just keep on going, right? So what will be your first term? 81 over 100. Okay, 81 over 100. Now, what will be the common ratio? 1 over 100, right? n to the n minus 1. Because you adding is going to be 0.0081. And then you can do summation. And then you can do 81 over 100 divided by 1 minus 1 over 100. Right? And whatever result is going to, whatever fraction is going to represent exactly this. So those are the things I did not teach you last week. I apologize for that, but we're going to move on.
Wait, how do you do there was one that had like a 0.075.
Oh, that was, so you kind of start at 1,000 and see how it's pretty fun.
Your first term is different.
Mm-hmm.
Got it?
Yeah.
All right. We're going to talk about the integral test. So what is the integral test? So how many different tests we have, right? How many type of series we have? That so far we have famous one, n equal to 1 infinity 1 over n. This one is diverge because of harmonic, right? We also have what else do we have? We have summation of a1 times r to the n minus 1, n equal to 1 infinity. That's equal to what? A over 1 minus r. And this is the only one that has sum. This is the only one. This only one has sum. Telescope has pretty close to sum too. Actually, telescope will be sum as well. So telescope series, which is usually is denominator is a factorable of rational function. It's factorable, right? If it's a factorable, then you can decompose, right? Then you can change to 2 fraction. And you write out first few terms to get it to telescope. And this will give you the sum. But that's only if it reaches infinity, so same thing is geometric. So this is the only one that has sum. So this one has sum. The other one is only diverge or converge. And the limits n approach infinity of a to the n. If it's not equal to 0, then it's diverge. So that's the thing that we have known so far. We're going to talk about 2 things. One is integral test. What is integral test? For integral test, if f is positive and continuous and decreasing. So it has a lot of pre-existing conditions. Says you have the condition for x greater than 1 and a to the n is equal to f of n. Then summation of n equal to 1 of infinite of a to the n and 1 to infinity of f of x dx, either both converge or both diverge. Now, what does that mean? If I do this improper integral of this series, of this sequence, if this sequence, even though it's series of a to the n, if that equal to a certain value, and you know is converge. If it doesn't equal the value, is equal to infinite, then it's diverge. Does that make sense? Because area underneath the curve, it's like a sum, it's summation of all the things, all the rectangles, remember? So we take in the summation of the rectangle here, we add them together. If it diverge, the sum has to be less than that. Does that make sense? Sum has to be less than that. Sort of, but sum is going to be less than that. So if this integral test is converged, then the whole thing is converged. Remember that if we have, but the function has to be positive, has to be above x-axis, and has to be decreasing. Right? If you take, for example, if you take this, right? If this area end up to converge, the sum had to be converged because sum is less than that. Because the integral is including all the fractional things, all the things. But here we just calculate the width is exactly 1 because we only count the integers. Does that make sense? So there has to be less than that. You guys look at me like, I don't know what the hell he's talking about.
It's divergent plus plus one.
What?
What is it divergent? We didn't get it.
If they both diverge, if the integral test is diverged, then it's diverged. The series diverged.
But it diverges if it's infinity.
Yeah. It's only in infinity. Now
Wait, let's see it.
yeah.
But the integral is not equal to the sum.
Integral does not equal to the sum. Okay, integral does not. It's close approximation sum, but it's not. So it's not like geometric or telescope. It's the sum. This is not a sum.
So isn't it more like you're doing like Riemann sum? Isn't that kind of what it is?
Yeah.
Okay.
But we only base on the integers. We use the width is 1 and we calculate that. Right? So we got pretty close to it. But doesn't mean, but if you do two integrals, let's just say you do Riemann sum between 0 to 0.52, you're gonna have pretty close. It's not exact, but it's pretty close. So, but if it's one's converged, one's converged, the other one is converged. If one's diverged, the other one's diverged. Now, it has to fulfill those 3 conditions. It has to be always positive, has to be always continuous. You cannot have non-continuous function. At least from 1 to infinity. Is that okay? So I called it CPD, COVID positive, and you die. Just kidding. I'm just thinking about acronym can help you remember. Disease.
Oh.
Oh.
Oh. No.
Wait, say.
What?
What were you gonna say?
Okay, so
Oh.
somebody say something.
No.
I think Robert has something to say to the class.
Yeah, I think Rob.
No.
Rock off.
I think that's the
Just
COVID
Positive
or positive COVID.
Positive COVID die. Okay. Whatever. I mean, I think first year I used something else. I don't remember what I used. Apply the integral test to the following series of n equal to 1, infinity of n over n squared plus 1. Now, before I do integral test, I must make sure, are they positive? Are they positive? Think about only 1 to infinite, not think about negative numbers, because negative numbers could be negative. Y is always positive. The top is only positive number, and the bottom can only be positive number. It gets bigger and bigger, but never have a negative element in there. So C is check, right? Or is C is continuous. So are they continuous?
I think so.
There is no asymptote. There was no gap. There was no jump. And positive? Are they always positive? Yes. Are they decreasing? We don't know. So what's the best way to prove decreasing? So, 2 ways. Algebra and derivative. In this case, I feel like the derivative is pretty easy. So low d high minus, I'm going to use x because that's a function, x. Low d high minus high d low over low low. This is f prime of x. So that's equal to x squared plus 1 minus 2x squared over, sorry, this is x squared plus 1 to the square. So that's a negative x squared plus 1 over x squared plus 1 squared. So the bottom part is always positive, doesn't matter what. Now remember, n is going to be greater than 1, right? You start with first term. So what is that always going to be end up to be? Number line test is always going to be what? Negative, right? So we only care about, actually we don't care about 0. We only care about 1 and up. So this is always positive. I mean, sorry, always negative, my bad. So it's decreasing, so we have checked this part. So now we can do integral test. So we're gonna assume it's 1 to infinity. Why is 1 to infinity? Because your terms start at 1. And there's x over x squared plus 1. Do you guys remember how to do improper integral? Limits b approach infinity of b of 1, x over x squared plus 1 dx. What kind of integral are we supposed to do here? U sub, u equal to what? X squared plus 1, du equal to 2x dx, which is nice, because that way I have a du over 2 equal to x, du x equal to dx. So that's going to be u and x and then du over 2x. So x cancel out. And then u is equal to x squared plus 1 half b natural log, sorry, this is natural log. Natural log of x squared plus 1, right? And sorry, that's gonna be limits as a b approach infinity between b and 1. Natural log of, so 1/2, sorry. Infinity squared, but b squared is gonna be infinite. B squared plus 1 minus ln of 2. Is ln of 2 matters? So that's 1/2 infinity, so it's going to be diverge. So this series diverge. So the series diverge because the integral tests diverge. So you're gonna try another one. Marcos, what's your question?
Just like fully comprehend it, because I understand when to find it.
I'm trying to just think about like what it actually is.
That means if the area under the curve is not gonna give you a defined value, your series not gonna give you a defined value as well.
Why did they choose the word diverge?
Diverge is not going toward a number, it's going to infinite. I don't know why they picked that word diverge.
That's what I'm trying.
Diverge is like this.
That's what I'm trying to ask.
Converge is like becoming one number.
Yeah. Okay.
Okay, so we have a summation of n equal to 1 infinite with 1 over n squared plus 1. So it's bottom factorable. No. I mean, it can factor, it will be n plus I and n minus I, but that will be way too complicated. No, I'm just kidding. I'm just kidding for not shaving. You do whatever you want.
Oh man, I don't know what to do now. Flip a coin.
Shave half. I'm just kidding. Yeah, you make an impression right there, whether good or bad. What is it? Good publicity and bad publicity. What did I say about good publicity and bad publicity?
There's no such thing as bad publicity.
There's no such a thing as bad publicity. Yeah.
It certainly make it fresh.
Yeah. You that means you have balls. They'll be like, yeah, I like this kid.
Brandon, just think about the fact of what you had to experience growing up here. You know what I'm saying? Would you want to go through that again?
They didn't want to wait. I didn't have to do anything. Yeah, but doesn't it go through that weird awkward stage where it doesn't look good?
Yeah.
So imagine what kind of discussion you're gonna have if you get shaved halfway. There's no like, yeah.
You just stay like this the whole time.
What's the point of shaving half of it then if I'm only gonna show them one half?
Conversations.
You can mog him with half your jaw.
This one's an easy one, but you do have to prove CPD on the test. Usually decreasing, which that's why we learned about monotonic before. CPD.
Good song, bro.
Marcos,
It's famous.
what'd you guys get us? What did you guys get? Converge to converge, but why is converge? Integral test is equal to what? Huh? Pi over 4 is good.
Yeah.
So it's equal to pi over 4. I don't need to show you the work, right?
No.
It's arctangent. Ah.
Wait, how did you prove the decreasing part?
Take a derivative.
With like power?
Chain rule. No. Quotient rule. Quotient rule, chain rule, it doesn't matter.
Do I have to prove it?
You had to prove it on the test.
But can I like algebraically prove it? Like, can I just like plug in 1, 2, 3, and then it keeps getting bigger?
You can prove like 1 over n squared plus n plus 1 square plus 1. It's always gonna be less than 1 over n squared plus 1. But I don't know how to, if that proof does prove. Is that gonna come out? I don't know. N squared plus 2n plus 2 is less than 1 over n squared plus 1. So it'll be n squared plus 1 is less than n squared plus 2n plus 2. 1 is less than 2n plus 2. Yeah, that's always true.
So that just means that
That means always decreasing. That's the second way to prove algebraically. Yeah, that's the algebraic way to prove it. So 1 is less than 2n plus 2 because n is 1 to infinite. So 2n plus 2 is always greater than 1. So you can prove this way, or you can prove using decreasing by taking the 2. Is that okay? I'm gonna re-talk about convert P series again. So I'm just gonna write down this to you. This is super easy. We already talked about this the other day. So n equal to 1 to infinite, 1 over n to the p is 1 over p plus 2 over p plus 3 over p, dot, 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 dot. Converge if p is greater than 1. Diverge if p is less than 1 or equal to 1 and greater than 0. That's it. So you can use this to prove harmonic series is diverge. Why? Because 1 over n equal to 1, infinity, you can say p is equal to 1. Therefore, diverge due to P series. So P series is P series test. Very, very important. Yes. What if I have n equal to 1 of infinity of 1 over n squared root n? Is that diverge or converge? Huh?
That is converge.
Why? Yes. Good job, Algebra 1. 3 over 2. Right? So 3 over 2 is greater than 1. P series says it's converge.
How do we find it with the P?
Because this is a P, right?
No, but how do we find where it's converges at?
We don't. We cannot find where it's at, but we can just say it's converge or diverge. That's the only thing. So only one, yeah, the only one that you have a sum is only telescope or geometric. For P series, you cannot find a sum and you cannot find things.
Okay.
And you just say, oh, yep, it's converged, done. Move on. Next question. What?
What does it say on the top right of the second page?
Diverge.
If the p equals 1.
Diverge due to.
Due to P series. Therefore diverge due to P series. Yeah, I don't feel like good handwriting today. You're gonna shave halfway and they're gonna ask you, why come shave halfway? They just don't feel like it.
Oh yeah, shave half of it and then the other half like.
We had this
Oh,
conversation.
My bad.
Where's a guy or girl?
Guy.
Yeah.
Oh my
I'm
goodness.
already. Emil took my interview spot from yesterday. I was gonna interview him. He's like, "Oh, we have somebody for that spot."
Rainer.
What's the interview question?
He asked about everything, bro. Like, he asked about my family for some reason. I don't know why.
What did he ask?
Bro, it's like, where are they from? Why did they come here? He's like an immigration. Why did they?
Are you even legal?
And then he asked why I
Dude.
That's the viewer too.
Well, I'm asking.
Oh, 1 plus 1
No, you
half.
I
exponent rule.
They scheduled the interview. I don't know when the interview is yet.
Oh, dude. And to the 1 half. And then it turns it, and then you add the exponent.
Andrew, if I were you, yeah, like that's basically like overview of things you wanna go over.
Yeah,
You have a
that's
grill?
what I said.
Okay.
Maybe something you should.
We're gonna be grilling hamburgers and hot dogs. Alright. We're gonna be playing nothing but sharp roasts on the roof.
Like schedule.
Garth Brooke? I like Garth Brooke.
There's a why us, that's the question. Oh, no.
How much time I have?
2 minutes.
Okay, I'm gonna just leave this one for you to do. Now this one slightly changed. Do you know why?
What book would you ever read?
What is it?
Oh.
N, L, N, L, what is it?
N 1 over or 1 over n ln of n.
Of N or to the power?
One times ln.
1 times N. Too many N's.
Showed up as a student. Like, they will get people like that too.
Now there's a reason why. Why do you think they start at n equal to 2 here? ln 1 of 0, so it costs undefined. So now your improper integral should start at 1 or start at 0? Or start at 1 or 2? 2, and that's it. And then you're gonna get diverge. And then
Wasn't there something about like how the first few don't matter much in the picture you sent? Convergence is not affected by the removal of the first few terms.
yeah, but I hear it does need it because I hear n equal to 1 is actually something over 0. So you cannot start at n equal to 1.
But that doesn't really affect if it converges or not.
I mean, you had to do integral test to find out. And you guys should know how to do integral tests on this. I don't know. I think you know. It's just an improper integral. That's why we teach you improper integral beforehand. Got it? Okay, that's it.
Is it diverge?
They diverge because they go to infinity. But you have to prove it's decreasing though. So that part you have to do on the test.
Are there cases where it would be DP but not D?
It has to be all three in order to do integral test. Possibly.
Oh, it might be that.
Because if you're not decreasing, right, the sum is gonna be infinite. It has to be decreasing to have even have a chance.
That's a fair question.
But and also because it starts at 2, there's not going to be an asymptote, so it's going to be continuous.
Yeah.
If it was at 1, then it would be 0, and then it would not be.
Diverge, infinity.
Wait, no, homework?
Bye. Marcos, is she upset
Who?
about ping pong?
No, you're overthinking. It was.
I just feel
Yeah,
bad.
no, there's nothing.
I didn't want it to. But I didn't want it to like. Somebody's gonna be like, why you let her play and you don't let me play? And then, okay.
I told her like,
She's
that's
talking
how it
about
is. Like, you can go and make your own rules. Like, that's how it is. And I
Yeah.
just-
But I suppose send a message beforehand. The day before, I sent it to AB group chat. I didn't send it to BC.
It's okay.
But then that way you wouldn't know. You will never ask me. because you asked me, kind of put me in the awkward position. So I don't want her to be upset because she's always been very respectful. Oh, she's right there.
And we're not allowed to use any words. You can't use any words now.
Oh yeah, you can have them, but like ideally when we prepare, you have to do them because it takes a lot of points. Like, as long as we don't stuff done, we need to work early though. You know what I'm saying? Because if we actually practice more, we're gonna know.
Why are you here, David?
Staying after school for drone rocketry meeting.
Drone and what?
Rocketry.
What is a rocketry?
Like rocket.
Who's the sponsor?
Rollerson?
Oh yeah, Mr. Bullock.
Is that
The black guy?
You trying to get people to join his stuff.
No. Like, I know.
I know it's bad.
He's got a flight simulation in his classroom, though.
Yeah, I've seen it. Looks pretty sick. My friend Jake runs the club basically.
Wait, what
but,
did he teach?
He teach pre-calc and algebra 2. But I heard he's not that good a teacher.
Come over.
I don't know. I had Chaparro.
Yeah, what?
Chaparro. 2 years.
Chaparro's good.
Yeah, I've only ever had 2 math. No, 3. Yeah, 3 math teachers. 4 never mind. Because I had Chaparro for freshman and sophomore year, and then you for junior and senior.
Yeah.
Then I also took stats and stuff.
Cooper.
That's honors and stats.
Cooper, right? Cooper this year, right?
No, I'm not taking it this year. I took,
Oh, you took it with what's the guy? He's cool. He's funny.
It was me $28.
Why?
He said, if you pass the AP exam, he'll give back the $50 you get from passing the AP exam.
You don't give nobody $50.
Yeah, I know, but like after taxes, it comes out to 28. So he gives the students back 28.
How he's gonna give it back? Give it back cash?
Yeah.
Did anybody got it?
No, because he left.
He did on purpose.
So
He's like,
he gave it to like other like past years. He gave it to his students.
oh, okay, that's
Just
pretty
ran
nice.
with the cash. I respect that.
He was a cool teacher. And I had honor for stats honors. He left to LVD.
Mhm. I've heard from like all the old calc students like Nick and stuff that stats is like comically easy.
Yeah, it's really easy.
That's fun.
Yeah.
That's honors sophomore year. What I do is I would like sleep in class, and then one kid he asked me to do his homework for him for money, and I made about like $200 off of him alone.
Jesus.
And then
For
like,
stats,
and then
that's like
word-
finding Ming and finding Mode.
Yeah. And then word got around that I did that for him, and then a bunch of other students asked me to do them also. So I made so much money.
Honestly, I can make so much money doing like algebra pre-calc homework.
Oh yeah.
So easy.
This always class last year. There was this one kid that I knew from middle school. He kept asking me to do his homework for him, and he's kind of dumb as shit. So I kind of manipulated him. I was like, yeah, man, I got a lot of work, so it's gonna be $40 for this assignment. It's like the easiest assignment ever.
And you
did
pay
like
up.
5 minutes. Yeah, he gave me like $40 every
It's
time I
like
asked.
convert 60-degree to radians.
It's like basic algebra and stuff. Elevate. Like rationalize this fraction.
Look who's here. What the hell were you today? Go overtime, you and Kevin? You'd be like 1, 2, 3. Where were you today? Sleeping? You're gonna choke tomorrow. You're gonna choke tomorrow.
I'm 78 calories today. I got one full breakfast.
Very terrible. Did your stomach go like crazy?
Yeah, it makes crazy noises.
Yeah. That's right. If I don't eat that,
Last week,
my stomach.
last week, I think on Thursday I only had 270 calories inside it.
Are you gonna pass out?
I passed out once, like last year, peak cut.